Okay, so I presume that all of you could see my share screen clearly, right? So just to make sure everyone could see my share screen, right? Okay, so I presume that every one of you could see my screen. So like the title suggests, today I would like to talk a little bit the statistics in Mahjong. Okay, so the objective for this talk will look something like this. So basically, I will try to introduce two concepts that is frequently used while playing Mahjong. So the first one will be on tile efficiency, and the second one will be on when we should be playing offensively and when we should be playing defensively. So basically, these two ideas actually relies on some statistical tools that we will try to mention a little bit in this talk over here. But before I go into the main content for this talk, allow me to make some disclaimer first. So for this talk, because we will actually try to mention some technical terms like 萬子, 筒子, 索子, or even like 清一色, 混一色, things like that. So for those technical terms, it is actually kind of difficult for me to translate them in English. So do bear with me that when I try to refer to those terms, I might actually be simply speaking in Cantonese, okay? But other than that, I will try to keep the English as the main medium for this talk. And at the same time, this talk does not promote gambling, okay? So the objective of this talk is trying to use mathematics as a tool and so as to improve your skills of playing Mahjong, okay? So because of the limited time for this talk, I won't be getting into the details on on what will be the basic rules in playing Mahjong. So I will actually assume that you know the basic rules on how to play Mahjongs, okay? And it could be any styles of Mahjongs that you know in mind. For example, it could be the Cantonese style, the Taiwanese style, or Japanese style, okay? So any style of Mahjong, as long as you have a basic knowledge on how to play them. And for this talk, we will only be considering standard yik-yings, okay? By standard yik-ying, it essentially means that you will need 4 面子 and 1 着头 in order to declare a winning hand, okay? And also, we only consider standard yik-zhongs. By saying standard, we are trying to referring to like maybe 自摸,平胡,清一色,混一色,對對胡, 東南西北,白發中, things like that. So we will try not to consider weird stuff like 七對子 or maybe 13腰, things like that, okay? We try to keep things simple, okay? And for this talk, we also try to assume that only 1 逆種 is needed to declare a winning hand. So by saying 1 逆種, it essentially means 一番起胡, okay? So like in the previous slide suggests, today we are going to talk and mention about two very important concepts for playing Mahjong. So the first one will be on tile efficiency. The foundation for tile efficiency actually builds on the randomness, okay? So randomness is actually a concept that is very important in statistics. And basically it means that each and every possible tile would equal likely to be drawn from the stacked tiles, okay? Equal likely would be the keyword, okay? And by saying randomness, it essentially means that there will be no prediction and there will be no superstition, okay? By saying so, say for example, if you consistently draw 4 만子, then you should not think that, oh, the 5th tile that I'm going to draw would also be a 만子as well, okay? Because by randomness, you cannot really predict what happened next, even if you draw 4 consecutive 만子, okay? So that is basically the idea or the spirit behind randomness. And in fact, using this randomness, we could build on the theory of tile efficiency. But before I go into the explanation of what tile efficiency is, I would like to have a little bit of interaction with you guys. So here I would like to have a simple poll, simple questionnaire. So here, I would like to ask a question, which is, so in the screen, you'll see there are actually two hands, A and B, okay? So my question is, which hand looks more appealing to you? Okay, so by saying appealing, it essentially means whether you would be more happy if you receive the A as your initial hand or whether you receive B as your initial hand, okay? So I'm not sure, I have already launched the polling, so I guess you should be able to do the votings right now. So I guess I will give maybe 10 to 15 seconds for you to choose between two of them and see which one looks more appealing to you guys, okay? Okay, so because of the time issues, I guess I will be giving 10 more seconds. So just some comments, when you try to judge which one looks more appealing to you, you may actually want to judge based on like whether it is going to be very easy to say or whether the file is going to be large or not, okay? So I guess I will end the polling right now. And on the screen, you should be able to see the results. So we have altogether 5 people doing this polling. And 2 of you think that hand A looks more appealing to you. And 3 of you think that hand B looks more appealing to you. Okay. So actually for this question, we do not really have a right or wrong answers, okay, to be honest. But through this example, we can try to do some comparisons between these two hands, okay? So basically for these two hands, you would expect that the fansel will come from 1-1and probably the Fat or the Dongs, okay? And if you are very lucky enough, you might possibly be doing the 對對胡 as well. But judging from these two hands, doing a 對對胡 would actually be something quite difficult. And on the other hand, you should be able to see that for both of the hands, you will need one more tile in order to progress to 聽牌 or 叫胡, okay? So say for example, in hand B, so you have now 14 tiles, right? So suppose you discard the 1索 and suppose subsequently you have the, say for example, the 9索, then in this case, you will probably be discarding the extra 1索and then basically you will be waiting for the 2索and at the 2索and also the Dong, right? So you should be able to see that in fact, for both hands, you will need one more tile in order to declare 叫胡 or 聽牌. So because of so, we will try to discard one tile, okay? So now we focus on hand A first. So in fact, we have quite a number of options. Say for example, we could discard 1索 and basically we will be happy if we would draw 2, 3, 4, 5, 6, 7, 8, 9 索 or a Dong in the next draw, okay? Or on the other hand, if you discard 4索, then basically it would say that if you are drawing 1, 2, 3, 4, 5, 6, 7, 8, 9 索 or a Dong, then you will be very happy. So we also have a similar discussion for this hand B over here, which is basically you could discard 1索 or 2索, and then basically you will be waiting the 2, 3, 6, 9 索 Dong or the 1, 3, 6, 9 索 Dong. Here, we can actually make one very important comparison between the last 2 bullet points over here. So for hand A, you see that we are actually waiting for altogether 26 tiles, okay? So the 26 tiles actually comes from these few, the 2, 3, 4, 5, 6, 7, 8, 9 索 and the Dong. So when you try to do the counting, you see that we actually waiting for 26 tiles. While for hand B, we will be waiting for altogether 15 tiles, right? So from these 2 figures, you should be able to roughly have a feel that in fact, hand A should be more easier in terms of getting to the stage of 叫胡, okay, or getting to the stage of 聽牌, okay? So in the previous example, like I said, we actually need one more tile in order to progress to 叫胡 or 聽牌, right? So we call this to be 一向停. Okay, we call this to be 一向停. And suppose you discard 1索, then we will be waiting for altogether these 26 tiles. So the 26 tiles over here is called the 有效牌數, okay, the number of effective tiles, okay. So as we are trying to play Mahjong, actually we can try to keep track of the 向數 and also the 有效排數, okay? So drawing a 有效牌 would actually decrease the number of 向數 by 1, okay? And for a fixed 向數, in fact, the more the 有效排數, the better, okay? Because from the theory of randomness, we know that if the number of 有效排數 is more, then it essentially means that you have a higher probability of getting the 有效排數. And remember, whenever you draw a 有效牌, so it will decrease the number of 向聽 by 1. So for now, we are actually in the stage of 一向聽, right? So suppose you draw a 有效牌, so then essentially this hand will progress to 零向聽 or 聽牌, okay? So 聽牌 is something good, of course, right? So based on this example and the discussions here, we see that in fact, maximizing the 有效牌數 will actually increase your probability of 聽牌, okay? Maximizing the 有效牌數 will actually increase your probability of 聽牌, okay? And essentially, maximizing the 有效牌數 will be the spirit of tile efficiency, okay? So allow me to summarize a little bit. Tile efficiency is actually a skill which allows you to form a winning hand in the fastest time, okay, in the fastest time without emphasizing the payoff, okay. So by saying fastest time, it is actually measured in terms of probability, okay. The more the 有效牌數, the more or the higher the probability that you will be decreasing your 向聽, okay. So here, we need to emphasize that in fact, tile efficiency here does not care what will be the payoff or equivalently what will be the number of 番數, okay? All we care would be the speed, okay? All we care is the speed. And therefore, tile efficiency will be very useful if speed is something that you are striving for, okay? And by using tile efficiency, it will help you determine several things like what tile should you discard. And then say, for example, if you see a tile that is discarded from 上家, then you could also use the tile efficiency to judge whether you could whether you could 上牌, 碰牌, or 降牌, and how you could do so, okay? So basically, all this will rely on the tile efficiency that we discussed previously, okay? So I suppose that most of you would understand Cantonese Mahjong. So in fact, Cantonese Mahjong might not be a Mahjong that promotes the speed, okay? However, there are actually some other Mahjong rules, say for example, the Japanese Mahjong, which actually encourage and promote speed. And in this case, tile efficiency would become a very important learning ground, okay? So in the previous example, we see that in fact, discarding 一索 and 四索 will actually resulting to 26 有效牌數, okay? So suppose, let us try to consider what happened when we discard 七索. So if we are trying to discard 七索, then essentially we will be very happy if we successfully draw 1, 2, 3, 5, 6, 7, 9 索 or a 東, okay? So when you do the countings, you should see that there are altogether 24 tiles. So we have 24個有效牌數. So when we try to compare these three numbers, we see that in fact the number of 有效牌數 when discarding 一索 or 四索 will be maximized. Okay, so in this case, we see that in fact discarding 七索 is actually a bad move because you see that the number of 有效牌數 is actually less than the previous two cases. And because of so, the probability of reaching 聽牌 will be less than the case when discarding 一索 or 四索. Okay? So now, can we further distinguish whether it is better to discard 一索 or 四索? So the answer is yes. Okay, so basically we try to project what happens subsequently after drawing the 有效牌. Okay, so here when you try to do the comparison, you should be able to see that in fact for most of the cases they will actually be the same. However, as you can see in the share screen, the 3 and the 5 are actually highlighted green. So we try to look more closely what happened when we draw a 三索 or a 五索. Okay, so suppose in the previous hand we discard 一索 And we further divide into two cases, which is drawing a samsok and drawing a umsok. Then in this case, you should be able to see that, in fact, after drawing a samsok, we will reach this hand over here. And naturally, we should be discarding the chatsok. Okay, so after we discard chatsok, then we should be already gilwu, okay, and we should be waiting for yi umsok and also the dong. Okay, yi umsok and dong. You should be able to see that the yao ha pai, so in this case would be 7. And similarly, if we draw a umsok, the number of yao ha pai so will be 11, which will be essentially waiting for 3六九索. We do a similar analysis when we try to discard say sort in the previous hand. And we also count the number of yao ha pai. So subsequently, when we draw a 3索 and 5索, and you should be able to see that, in fact, the number of yao ha pai so would be way less, okay, when we try to compare to the previous case. So in this analysis over here, we should be able to see that, in fact, discarding 一索 is the best move. Okay, discarding 一索 is the best move. Okay. So I have already taught quite a number of theories and examples behind the tile efficiency, and now it is the application time. We will now be having the second pole over here. So in this pole, you should be able to see that we have this hand. So the follow here essentially means that you have already 上牌. Okay, you have already 上牌. Okay, so basically it means that all the other players know that you have these two minties. And so in your hand, you are only left with these tiles. So the question here is, which tile should you discard based on tile efficiency? Okay, so I have just launched a vote over here, and you should be able to do the votings right now. And in this case, we have altogether 4 options, which is 1索, 3索, 7索, and also the 8索. Okay, so you may want to try and do a little bit of counting and see what will be the number of the tiles that we would be waiting when we discard 1索, 3索, 7索, or 8索 subsequently. Okay, so essentially we are trying to count for what will be the 有效牌數. All right. So I will give you maybe 30 seconds to think over a little bit. So again, don't worry about like voting for the wrong answer, because basically, I mean, even though that the tile efficiency is one of the theory to help you determine which tile should be discarded optimally, when you really try to play a real game, there is really no right or wrong answers. Okay, so do feel free to do the polling, do the votings over here. Okay. So time is running out, so I guess I will probably end the polling over here and see the results. And we have 1 people voting for 1索, 2 voting for 7索, and 2 voting for 8索. Okay, which is good. And now let us try to see which should be the correct tile to discard based on tile efficiency. So in fact, when we discard 1索, you should be able to see that we are essentially waiting for 3六七九索 and also the dong. Okay, when you try to do the counting, you will see we are actually waiting for 11 tiles. The number of 有效牌數is 11. Similarly, for 3索 and 7索, you should be able to see that in fact 有效牌數 is 13. So in fact, discarding 3索 and 7索 should be the most optimal in terms of tile efficiency. So in fact, like I said, there is no right or wrong answer to this question. So either discarding 3索 or 7索 will have its benefit, okay, based on the tile efficiency. So in fact, we will try to again compare subsequently what happens. Okay, so we will only be focusing on what happened when we subsequently draw a 六九索. Okay, so essentially, when you discard 3索 and you draw a 六九索, then it actually forces you to discard the remaining 7索. Then in this case, you will be able to see that you will actually forego the possibility of 碰東. Okay, when you try to compare with the case of discarding 7索. Okay, but again, like I said, it could be the case that dong would be something that would be very difficult to be discarded by other players. So in this case, then you might actually think that discarding 7索 is better. But if you think that people would actually discard dong, then maybe discarding 3索 might not be a good choice. Okay. So that is basically the concept of tau efficiency. And now we try to go into the discussion of when we should be offensive and defensive. So for tau efficiency, the whole theory actually builds on randomness. Okay, while for when to be being defensive and offensive, it actually builds on the theory of law of large number. Okay, so law of large number is actually a very useful and popular tool that frequently encountered in statistics literature. And it essentially means that the long run average to a random outcome will actually converge to its expectation. Okay, the keyword over here is long run, meaning that you will actually play a lot and a lot and a lot of games. Okay, such theory that I'm going to present might not be useful if you are only going to play Mahjong for one round. Okay, however, if you are going to play Mahjong for a lot or multiple rounds, then in what follows, it might actually be useful. Okay. Before I go into the discussion of how the law of large number would be useful, allow me to again make a simple polling here again. So here we are trying to participate in playing a game. Okay. So in this game, we actually have different scenarios. Okay. So basically, it says that for each of different scenarios, we will be having different probabilities of winning or losing the game. Okay. So say for example, in option A, the probability of winning is 0.5 and losing is also 0.5. And when you win, you will gain 1 point, and when you lose, you will lose 1 point. So on and so forth for option B and C over here. And my question is, which one you would like to participate in? Okay, which one you would like to participate in? There is also an option that you would rather not to participate in any of the above games. Okay, so I will give maybe 10 seconds for the voting. Okay, so I will end the vote here, and I see that actually the majority of you will choose to play in the third game, while one of you will be playing the second game and one of you will not be participating in any of these games. Okay, so honestly speaking, again, there is no right or wrong answer to this question. But again, through this example over here, we can actually try to do some comparisons. So actually, we can try to use a computer and simulate what will be the outcome of playing game A, game B, and game C for a large number of rounds, okay, for a large number of rounds. So here I try to simulate the result for a together 1,000 games. So for game A, you should be able to see that in fact, the long run average point that you will gain is roughly 0. For game B, the long run average gain of point is roughly 0.1, while that point for game C is roughly 0.2. So the 0, 0.1, and 0.2 is no coincidence. Okay, so the 0, 0.1, and 0.2 is actually what we call to be the expectation. The expectation here is interpreted as the weighted average of the points that you will win or lose, weighted by the probability. So say, for example, for game A, the expectation will be 1 multiplying 0.5, and then adding or subtracting the 1 multiplying the 0.5 over here. And you should be able to see that, in fact, the expected gain or expected loss will be 0 for game A. Similarly for game B and game C, okay? So in this example over here, we see that in fact, when we try to consider the game C over here, okay, when you only try to play a small number of games, you will actually expect that occasionally you will be having a positive cumulative gain, or a positive or a negative cumulative gain. Okay, as you can see from this plot over here, occasionally it will be above the x-axis and occasionally it will be below the x-axis, indicating that the total points that you gain will occasionally be positive or negative. So in this case, we interpret that in fact luck would play a factor. Okay. However, if we try to play a large number of games, then you should be able to see that in fact on the right hand side of this graph over here, it will consistently be having a positive gain, okay? So the interpretation will be that the effect of luck will actually diminishes, okay? The insight of this example over here is that if being offensive will generate a positive expectation, then you should actually be offensive. Otherwise, you should actually be defensive. Okay? So we try to summarize what the theory of offense and defense here is about. So essentially, the theory over here will help you to determine an optimal move based on the expectation analysis. Okay, based on expectation analysis. Here, the offense and defense theory here will aim to improve the long-term performance. Okay, it aims to improve the long-term performance. Okay. So the long-term performance could be reflected from the cumulative points that you obtain, or it could be the ranks under the context of a Mahjong game, okay? Here, we have some several assumptions for such theory to be applicable, okay? The first one would be that we assume that the Mahjong rules that you play across different games will be consistent, okay? Or in another word, there should be no house rules, okay? There should be no house rules. The second assumption is that we are actually aiming for improving the long run performance, but not the short term performance. Okay, long run here is the key. Okay. So as you can see, the theory of offense and defense actually relies on estimating the probabilities and also estimating the payoffs. Okay, so for the payoff, the calculation should be rather straightforward because you could estimate the payoff using the number of farm souls. Okay, however, the difficulty will be on estimating the probabilities, and in fact, it will rely on experiments and data collections. Under the context of Cantonese Mahjong, in fact, there are probably none research that has been done in this regard. And basically, the reason is because there are actually quite a broad spectrum of house rules across different people, okay? Say, for example, someone may play 一番起戶 or 三番起戶, someone may play 有花 or 無花, okay? And the payoff system would also be different as well, okay? 辣辣雞 or 半辣雞, okay? And on top of this, there are actually no centralized platform for the data collections, okay? And because of so, applying the theory of offense and defense theory for playing Cantonese Mahjong might be a little bit difficult. However, for Japanese Mahjong, actually, all these probabilities are well established because of the competitive nature in Japanese Mahjong. So because time is actually running out, so I won't be going into the details on the explanation of these graphs, but just to demonstrate, say for example, in this graph, we are trying to study the relationship between the 秦目, the 向聽, and also the 和了率. The 秦目 here essentially means that for how many tiles you have already drawn from the stacked tiles. Okay, so suppose you already drawn one tile, then it will be in 一秦目. Suppose you already drawn 6 tiles, then you will be in 6秦目. And essentially, the more the 秦目, in theory, the better should be your hand. Okay. Hand thing is something that I have already explained in the previous slides, and you should be able to see that in fact from this graph over here, so you see that in fact for the less the number of hunting, the higher the probability of winning. Okay, and also the probability would also be affected by the number of 秦目. Okay, so essentially you should be able to see that. Say, for example, for the same number of 向聽, say, for example, 零向聽, which essentially means you are already 叫戶. If you are already 叫戶 at the very beginning, then you have roughly 70% of the chance winning. However, if you are reaching until the very end of your gameplay, say, for example, 15 秦目, and you are 叫戶, then you are only having roughly 20% of 叫戶. Okay? So this diagram here tries to demonstrate the relationship between 秦目, 向聽, and 和了率. In this table here, we try to demonstrate the relationship between 秦目, 負路, and 向聽. 負路 here essentially means that for how many 面子 you have already 碰 or you have already 上. Okay, so essentially the more the 負路, the closer you should be reaching the state of 聽牌. In this table, we try to summarize what will be the relationship between the probability of already 零向聽 or already 聽牌 with the number of 負路 in different 秦目. Okay, so as you can see from these diagrams over here, for Japanese Mahjong, we actually well established these probabilities, and actually it would be very useful to help you estimate and determine whether certain strategies will be giving you a positive or a negative expected payoff. Okay. So my original intention is to demonstrate uh, some real case examples, but however, because of the time here is running short, so I guess I won't be getting into the details over here. But essentially, the main message that I want to illustrate over here is that for Japanese Mahjong, all these probabilities are actually something already well established. And at the same time, because Japanese Mahjong are actually a game that is emphasizing your long-term performance, okay? And because of so, the idea of or the theory of when to be offensive and defensive becomes very important and very useful, okay? So to conclude this presentation, basically we have introduced two concepts. The first one will be time efficiency, and the second one will be to decide when we should be offensive and when we should be defensive. Okay, so bear in mind that these two concepts are actually very important to help you judge which tile to discard and which action you should take. In particular, whether you should sung or a pong or a gong. Okay, and whether you should be discarding some dangerous tiles or whether you should be playing safe. Okay. So these are basically what I would like to share with you guys in this presentation. And now we will have some time for question and answer. Okay, so if you have any question and answers, if you have any questions in mind, please feel free to ask so in the chat room. Okay, and I will try to answer them one by one. So we actually have a question from the audience, although the question is sent to me privately. So the question here asks whether the theory will be applicable to stock selection. Okay, so technically the stock selection will be actually another very broad topic that we could discuss. The underlying theory for stock selection, of course, also relies on statistics and probabilities. Okay, so what I could tell you is that the theories that I introduced in this talk might not be something directly applicable to stock selection. Okay, however, the idea of randomness and also the idea of law of large number would also play a part in the stock selection. Okay, the only difference is that we will no longer be doing the computations in such a straightforward way. Okay, because for Mahjong, after all, we are only trying to improve our skills. Okay, the ultimate goal is for improving our skills, but for buying or selling stocks, the motivation behind or the objective behind is a little bit something more different. Okay, it might have something to tie with your financial planning, or it could have something to tie with your retirement planning. So one has to be very one has to do the calculations in a very careful manner. Okay, but for Japanese Mahjong, because ultimately we are for entertainment purpose, right? So the calculation might be a little bit loose. Okay, so basically this would be the difference. But like I said, the idea behind would also be something that would be used in the stock selection. Do we have any more questions from the audience? All right. So if no questions, please do bear with me for making some advertisements. So basically, it will be on the promotion of the programs that are that our department offers. Okay, so I presume that most of you should have already heard of the actuarial science program. In fact, such program is also introduced in some of the previous talks in this series. So here I would like to take some time to introduce 4 other majors that is offered from our department, which is the statistics program, the risk management program, the decision analytic program, and also the applied AI program. Okay, so essentially all these programs might actually be something that would fit under the context of the Mahjong that we just discussed previously. So for statistics, it is essentially to understand uncertainty. So under the context of Mahjong, it will be, say for example, to design some experiments and to collect data and to analyze the Mahjong data as well. And of course, we will try to draw some conclusions in it. So all these things will be under the context of statistics. Okay, while for risk management, it will be to study scientific method for risk management under different contexts. So of course, if you are really doing risk management in practice, then mostly the context will be under a business setting. But however, for the Mahjong setting, it will still be something relevant in the sense that you should be, or you will be reviewing your Mahjong skills consistently and see whether there will be actually new tactics, okay, and how it would impact you. For decision analytics, it will essentially be referring to the extracting of knowledge from structural or unstructural data. And honestly speaking, for decision analytics, it will usually be used under a business context. So actually it has less to do with the Mahjong. And lastly, for the applied AI, like the name suggests, it has something to do with the AIs. And I'm sure that the term AI would not be something not heard of, okay, or something new to you guys. So basically, it refers to designing and training of AI so that it will know how to do some tasks, okay? The task could be like playing Mahjong optimally under our context, okay? And actually developing of such an AI would actually be helpful for you to review your Mahjong gameplay as well, okay? So basically, this will be the 4 programs that is offered by our department on top of the actuarial science program. So hopefully you will be interested in any one of these programs, okay? And this is pretty much what I would like to share in this talk. So thank you very much for listening to it and enjoy playing Mahjong. And most importantly, hope to see you all in Hong Kong U in next year.